Hey guys, today I'll be bringing you something a little bit different here. So what we're looking at is a 2016 Minimoog Reissue, and it's actually here. It's from a client of mine I've done a lot of work for over the years, and he started having some issues with his Minimoog, and it's mostly just dirty switches. The range switches are really erratic in frequency, so you'll set it to 8 footage, for example, and the oscillator just kind of sits there and wavers in frequency, just from bad connection in the rotary switches. But he was also telling me too he wasn't very happy with the sound of it, and so I'm also going to be looking into ways to improve the sound a little bit. He couldn't really explain it to me that well as far as what he was experiencing, but I've been doing some A and B comparisons to vintage Minimoog, 1972 Minimoog, and I can kind of hear, I think, what he's referring to. So number one issue that we've got with it, besides the erratic switches, is if we set this thing to 16 footage, that's actually 32. If we go to 32, it's too low in frequency. It just clicks down here at the F note. So that's number one, and I don't know if that's a transposition software in the actual programming, because this is a digital keyboard. It's a digital keyboard running a microprocessor to generate the CV voltages needed for the actual original keyboard circuit. So I don't know if there's some kind of transposition that you can do in the keyboard from powering it off, maybe hold a note and turn it back on or something like that. I don't know. So I got to look into that. So it may just be a transposition thing. But that is a big thing because when you go to 32, it's just too low. And that is one thing I've experienced with the Voyager as well. You know, 32 is not 32 on the Voyager either. It's too low in frequency. But that's one thing I've ran into. The other thing I found out just by listening really close, and it's not drastic, but it is something I have picked up on, and that is there's a lot of distortion in the filter itself. So the filter, as far as the emphasis and cutoff frequency, they work fine. The filter tracks the keyboard, it calibrates fine. But if you set this thing to a threshold of almost self-oscillation, and you turn all 3 oscillators on and you have a good harmonic going, and you sweep the cutoff, there's a certain point where it just gets really muddy from the distortion that's inside this filter. So now this is not the same kind of distortion you hear me talk about when we talk about gain staging changes between early Minimoogs and late Minimoogs. This is more inside the filter rather than on the area between the filter and VCA. So it's just got a little bit more distortion inside the filter, so I got to look into that. But besides that, this thing's great. I mean, it's the way it's built. It's built very much like a vintage Minimoog. The chassis shapes and everything, all the metal work looks like it should. And you know, having this extra LFO is really nice. That is something I do to vintage Minimoogs on occasion, is I'll add a jack in the back so you can actually use your modulation mix control to route external sequencers or external LFOs into your Minimoog instead of using oscillator 3 as a source. But I'll take you around back here and just kind of show you what this thing looks like inside. So it is a Minimoog, as mentioned. It's a version 2 oscillator board. The same thing we find in my Minimoog, version 2 oscillator. They look different because we were talking about vintage versus modern. So they're using new components and that kind of stuff, where this is vintage. But that's the oscillator version 2 oscillator board. Here's your filter circuit and all that good stuff. Now they are using TS97 transistors, but I don't know if they really are TS97s. So I'm going to look into that as far as the distortion I'm hearing. It may be these transistors are not quite the same. So I'll be looking into that as well. And probably just going and pull them all out and rematch them, make sure they are matched, because that does affect your harmonic content. But same thing here. We got the transistor ladder here. Exactly same board. Reference oscillator, external audio input, VCA. There's really only 2 differences that's inside this thing that are drastic. So number one, if we look at the vintage one, we've got power coming in on the power cord, transformer, and then we got the rectifier filter board here for making your unregulated DC voltage. This one here, you lose all that. You can see you don't have the transformer or the rectifier board. And then what they got an external power supply. So this is a Meanwell supply generating the plus negative 15 volts and a plus 5 volt digital voltage for your processor. And then it comes up here and it plugs in, and then what they're doing is they're taking the plus negative 15 volts and regulating it down again using the original power supply. And so they're using it to make the negative 10 and plus 10 volts that are used to run the Minimoog. This is kind of how they're doing that. Now personally, this is just my opinion, but I do think this is kind of a janky kind of design here, because when you talk about performance instruments, you don't really want to have to keep up with some special proprietary power supply setup. You know, you want it to be IAC jack, because you can buy IAC cords anywhere. Even Walmart still carries them. You can plug that in and not have to worry about trying to keep up with this supply on the road. So that is one thing I would say. It's kind of a janky kind of thing, but it works. You know, if you're in the studio, this would be no problem. You know, the studio life, absolutely no problem. So that's number one. The other thing I've ran into, and this is actually be something I'm going to have to look into with this unit, is that all the rotary switches and pots and switches in general are all on this main circuit board. So I actually solder a through hole to this giant circuit board here. And so in order to clean 3 switches, I got to drop the whole board in order to clean all this. Now it may be split somewhere in the middle. Usually there's 2 boards, I would imagine. But I have to take basically all that apart to clean 3 switches that are dirty. Whereas the old vintage Minimoog is all hardwired. You got hand wired harness in there, and you can see the back of the switches and pots and everything here. So all I have to do is pull the oscillator board, the keyboard circuit, and I've got access to, you know, the harness and the switches and the pots and all that good stuff. So this is I got to tear apart a little bit farther. So that could be a nuisance for a technician. And I don't know, I may have to pull all the jacks as well. I may have to take all this thing apart. So that could be definitely something for technicians to keep in mind if they work on a reissue. I'll document that as I go through this one. But just want to take a minute here and show you guys what's inside this thing, what it is. It is a Minimoog. And like I say, with the few things I've ran into, they're not huge, but it is something that if you're looking for that tone, it could be a problem. And like I say, I don't know if all 2016 Minimoogs are like this or not. This may just have a problem. You know, so there's things like that I do run into even with vintage Minimoogs. You know, sometimes they don't all sound exactly the same, and I have to find out why. So that's what we're going to be doing in this one. But I'll hook up and let you guys hear a direct recording of this thing before I do the work, just so you can kind of hear what I'm talking about, and then we'll go from there. Alright, so anyways, I'm going to start here just by giving you a demo here, just a quick rough demo between the two. And like I say, they sound very, very close against each other. So they did a good job on this 2016 reissue. But I'm going to start with the oscillator section. So I'm just going to compare one oscillator, and I'm going to show you the differences here. So we're on 16 footage in this Minimoog here. We're on 32 footage here. So if we hit the C note here, the lowest C note, there's the original, there's that one. 16, 32. If we go to 32 footage on this one, look how low it is compared to that. That's the F note. It's just a click. So it's going down a whole extra octave than what it should. I did actually try in between taking the last video and this video direct of actually trying to hold down the key while power, see if it would be a transposition issue that way. Didn't have any effect on it. So that did not seem to solve our problem. So it is something I got to look into there with the 32 versus 16. But also, if we listen to the filter, I'll combine all oscillators together. See what? We'll go to their waveforms right quick. So we'll go to this upper F. So we're back on 16 footage here on this Minimoog, 32 on this one. So we're listening to Sawtooth. Let's go to sine wave. I'm going to go up. So as the original versus the vintage, we'll go to triangular. Then we'll go to Sawtooth. As you can hear, square wave. Then we'll go to pulse wave. This is not the narrow pulse. A little bit difference there, and then we'll go to the full pulse. So like the vintage Minimoog's got a little bit more narrow pulse width between the two last pulse width settings. But that's the waveforms. We'll go back to Sawtooth here. We'll combine all three oscillators together. Also, I will show you this right quick on this Minimoog. So if I change octaves, this is where you'll hear the noisy pots. You'll hear it mostly on oscillator 3, but this one here does it as well. So you can hear oscillator 3 is really bad. So there's all three oscillators on, but you can hear the noisy rotary switches there. So here's all three oscillators on the vintage. Let me tune them up just a hair. And there's a difference. And that one sounds just a little fatter, but not bad. Let me actually go and tune up my... See here, this is a little bit more brighter sounding than this one. This has got a little bit darker tone. I have a broken contact on this one I forgot about. This is my personal unit, and you can hear it just keep going up. It's got a broken contact. So we'll go. It also shows you the importance of detuning, because this one detunes kind of naturally. It's phasing a little bit. This one's not. Even though it's a version 2 oscillator, it's a lot more solid than this Minimoog. We got all the waveforms exactly the same. Filters opened up all the way, so nothing's different there. We'll turn filter tracking off, see if that has any effect on the sound. So there it is. So that's all three oscillators, full mix on both units. So that's the waveforms all together. Now the filter is also a little bit different on this one. I have found out just where the cutoff frequency sets. Now that it does calibrate and everything. And there's a little bit more distortion in this particular Minimoog, as I was mentioning earlier. So if we close the emphasis, we're going to set the emphasis to 8. And I'm going to sweep through the cutoff, and around -2, between -2 and -1, you hear a little bit more distortion in this particular Minimoog. There we're on -2, so you can kind of hear that filter. We'll do the same thing to this Minimoog. That was the note reference, making sure I got the right note reference. So same note reference here, same effect. 8 on the emphasis. And you can hear how cleaner this one is. You hear more of the harmonics coming through than you do on the Reissue. Once again. You can have a little bit more distortion in this filter versus this one. You know, all those harmonics. So if we put it in self-oscillation, so we'll do hard self-oscillation, no key tracking. And those harmonics play off that filter frequency. So same thing on this one. You can hear you don't quite have that same. But you hear it's almost a frequency higher, even though it's. So there's two Minimoogs. That's like a frequency higher. Let me see if I match that frequency. So you hear that filter just kind of sets at that same level, where this one actually interacts with the harmonics of the oscillators. That one doesn't quite do it. And that's just something I've noticed there. But the filter, as far as this tracking, we'll turn tracking on. Let's turn tracking on both of these. I'm going to put on 440 Hertz. We'll turn off the oscillators. And this is also something I've noticed too. The knobs are different positions for our tracking. So if we go here, let me get this one. Turn that one off. Alright, so now we got both filters tracking. So on this one I'm setting at -1, this one I'm setting at -2 for the key tracking. So as you can hear. So the filter tracks just fine, just a little bit different settings there. That's the bad contact. So here they are together. So anyways, you can hear how that sounds. So the filter sounds pretty good. It's not quite as organic as the original, but it does work. And once again, that could be because of new transistors. That could be a lot of factors in that filter. And that distortion that you hear, that's the only thing I don't like about this reissue, because it does cover up some of the harmonics that you get when these oscillators are combined. And that's also, I think, what's happening when we're listening for the harmonic content of the filter that we were earlier, because that distortion's kind of covering up what would normally be the harmonics off those oscillators. So if we're going to set this filter up here, and we'll go in and just do a contour sweep here. Now that's also a little bit different, I believe, on this one as well. We'll set it to 6 on both the amount of contours, 0 decay, zero attack, 0 sustain level, and we got the decay set to 1 on both of these. And so here's the reissue. Make sure our filter set up the same way right quick. Yeah, this has got a little longer time. That one's shorter, and you can also hear that distortion just in that. So in order to match that sustain time, or that decay time, I'm a little above 600 on this one, between 600 and 700 on the decay time of my vintage one. This one here is at 1. Both of them together there. So they actually match the amount. So this one's actually got a longer time in the decay or in the envelope circuit, because to get this to match up to 1, yeah, I'm on 5 on this one to get 1 on this one. So this one doesn't have quite as long of a decay time as the vintage one. That's the only thing I've noticed too there. But as far as everything else goes, I mean, it's a Minimoog. You can still get that same thumpy. This one sounds a little bit more boxy too. So you can see this one's still got a brightness to it. And once again, the cutoff knob is always a little bit different. So this one's a little below -2, this one's a little above -2, so just a slight variance. And that could just be the taper of the potentiometers that's in the reissue. So anyways, that's the 2 Minimoogs. I just want to document that, because what I'll be doing next, I'm going to be studying the filter a little bit, and also clean up these switches, these rotary switches. And of course I'll bring you guys along the journey when I have everything opened up, and we'll take a look at the circuit boards. Actually, I might even pull the circuit boards out of mine just so we can do a direct comparison here. But we'll kind of see how things go. My time as well, because I have other clients lined up as well here. But we'll see how things go here. But definitely going to clean the rotary switches and get this Minimoog fixed on that side of it. But anyways, at least you guys can kind of hear the similarities and the differences between the vintage and the reissue. Now this is a real vintage. This is 1972. So not all Minimoogs even sound like the early 72 Minimoogs. So it is a little bit different instrument. But anyways, keep you guys updated here. Alright, I've got the interface board pulled here, or at least the left hand side of it, and getting ready to clean these rotary switches and all that good stuff there. So overall the board looks really nice. These are your resistors for your voltage divisions for your footages. They've included them into the board. The only thing I'm a little shocked at is I'm surprised they used Alpha brand potentiometers. These are your cheaper components here, especially these rotary switches, and that's exactly I think what we're having issues with it is the plating materials they use on the actual contacts is just a cheaper, a cheaper grade, and also they're open. You can see they're an open design, so you can actually see the guts as you rotate this. What that means is they're going to be more susceptible to dust and that kind of stuff. So that's something that I was a little shocked to see. It's not terrible. Like I say, Alpha's not bad. You find Alpha used in synthesizers.com modulars and that kind of stuff. But they do tend to have a tendency to get noisy, dust in them, and they're just a cheaper pot. And so when I say cheaper, so when you look at something like Burns brand, like Burns who manufactures potentiometers, or even Alps, they got different grades of Burns. Now Burns is not cheap. They're pretty expensive for they're really high-end pots. They have different grade levels, so you can go from a cheaper Burns to a more expensive model. But basically what separates some of these brands is actually the life cycle. So what companies will do is they'll actually put these things through a test, a stress, to see how many revolutions it takes before something wears out. And so they're looking at both the carbon track, the carbon readings. They're looking at the actual mechanical aspect of the potentiometer. And so your more expensive ones actually will have certain things inside to help with the carbon wear. And they'll also have, sometimes they'll have brass bushings inside of your actual shaft. So your bushing is actually like your bearing of your pot. So it keeps it from wearing out and getting wobble in it. Because when you get wobble in these things, or wear inside that bearing area or bushing, you start getting bad connections in your carbon track because you're actually moving that wiper off the carbon. So with your more expensive pots, they have a lot higher life cycle, and also a lot of them you can buy that are sealed. So they're kind of like the old Allen Bradley potentiometers you find in the old Minimoogs. 50 years later, most of those are still good. They just need a good cleaning, because we're talking 50 years. So that is a factor. But that's just something I have ran into. It's not a big deal. Like I say, I'm not saying this is going to completely kill your Minimoog, but it just is something shocked to see for the price point these things go for. But also, when you open these things up for you technicians out there that have to work on your Minimoog or somebody's Minimoog, something to keep in mind, because I ran into this when I opened this one up, is you got these little spacers that go actually on your rotary switches. So they only go on your rotary switches, like so, and they fill the gap between the interface of the chassis and the rotary switch, so you can tighten down at the front when you put the nuts on. So that's something that I ran into. I actually took this board out and I heard it sound like a rain stick, and all these things were falling to the chassis of the Minimoog. So I had to go chase them down and get those back on there. So that's just a note for you guys, you technicians out there. Looking inside the chassis, I've got this board out, of course. Something I ran into was getting this board out also was a kind of a fight. I had to kind of finagle it through this chassis because I have the standoff here still in there. I could have probably removed it and made myself a little easier, but it fits that hole right there. So I had to kind of like work the board out. And it is a two-sided board though, so you got a left and right interface board, circuit board there. Plugs in right here on that connector. But looking inside, one nice thing is I did find out that the standoff for the keyboard circuit is machined in. So this thread right here is a machined in thread. So you don't have to worry about that coming loose or trying to tighten up in this thing, turning inside the chassis, which is nice. And they are using lock nuts for the chassis assembly. Now on the old Minimoogs, these would have been rivets. These are good. Screws with lock nuts is perfect. The one place you will want to put the washers, as mentioned earlier, is on this standoff here, this standoff right here, and there's one actually here at the top. And these are actually what holds this board in place. And those, like I was saying, when I took this thing apart, these things had backed out because there's no lock washers, there's no Loctite, there's nothing keeping those screws tight. And so they backed out. And so what I would recommend doing is go and getting you some washers. Flat washer with a lock washer would be preferable. That way you don't eat into the board with the lock washer. It just kind of saves your circuit boards. But also make sure you get a thin enough washer that's not going to, touch anything. I think these things are pretty good. Let me actually take these spacers back off here so I don't lose them again. Let me pull these off, because I've already done that once. Turned this board upside down and knocked them all off again. So yeah, you just want to make sure that your washers are going to fit without touching anything. And I don't think you have a problem, because this one right here you can see one component right there by that one where it's soldered in. But everything's a ground plane on the back here, so I think you'll be okay by using just a nice washer there. But so washer, and then lock washer, and then screw. And those are number 4 screws, 40 thread, and they're probably like a 1/4 inch in length. But you could probably go even look like a 1/2 inch if you needed to get a longer screw in order to fill the gap for all the washers and everything. Excuse the train coming through. But that's what I would recommend, and do the same thing for your, let's get this train get by. There we go. So, and do the same thing for your keyboard standoff, for your keyboard circuit board. put some Loctite there or washers, because they also came loose, and they were kind of floating screws at the top. Same thing for the power supply, exact same thing. They just didn't put any lock washers or anything in there. I'm kind of shocked at that too, because that's just, you know, common sense usually when you mount boards. But besides that, I'll take you around the bottom here and just kind of show you what the inside looks like at the bottom. So we've got a ribbon now coming out instead of a wiring harness. So it supports your left hand control, your keyboard, MIDI, all that kind of stuff there. But we go to the bottom, and this is where it gets drastically different from a vintage Minimoog. So here you can see that we've got the FATAR keyboard now in here, where you would typically sell your contacts for your Pratt Reed keyboard. And then this is the actual microcontroller right here. This is what handles the digital circuitry to analog configuration for the CV voltages to run the Minimoog. Your gates, your triggers, all that kind of stuff is handled by this board here. So you no longer have the resistor chain and all that kind of stuff like you find in a vintage Minimoog. And also the left-hand controller has more circuitry. And I believe a lot of that is for the aftertouch, your aftertouch circuitry, and that kind of stuff. But you can see I also use a Norland era style sticker just to give it some character. And it's serial number 208 on this one, built August 2016. So just thought that was kind of neat too. Kind of neat they kind of stuck with the originality of it. Now the sticker's a lot larger, but just kind of a neat little thing they added there. But anyways, I'm going to get this board cleaned up, get the rotary switches inspected and cleaned, and then I'm going to start reassembly here. Alright, I'm back on this Minimoog this morning. It's been the weekend here, so I'm back on it this Monday morning. And what I've been doing is just taking comparison readings between the vintage one and the new one, and taking gain stage readings and all that kind of stuff to see what we're looking at, peak-to-peak voltages, all that good stuff. But I started realizing something. I had an issue with the intermittent output on this reissue. And I noticed I could flip some switches on the front and then have intermittent decrease in volumes, and then I get some kind of a staticky noise, and then the VCA would drop out and that kind of stuff. Well, I found out what's going on with it. It's got something going on in the right hand control interface board. I already fixed the left hand. That's where I had to clean the rotary switches and all that, but this is the right hand side now. And you can see that we got signal. We're looking at the second half of the VCA, exactly same spot as we are looking on the vintage Minimoog here. And I've got a key pressed in so I can see the VCA is working. And I sometimes lose the signal. So, and I found out what it is. It's in the interface. So if I just go down here and I touch the edge of this board down here, you'll see that we'll lose signal. Boom, it's gone. So we've lost signal. So I've chased it down to either a cracked solder joint or something on that front board that's a problem. And so I got to figure that out before I can move on to the rest of the testing here. So I got to pull, and it looks like for getting this side of the board out, I got to pull all the jacks in the MIDI jacks. And of course I've already got the power supply unmounted at the bottom here, because I was already investigating just by pushing on different parts of this interface board. And I found it is down here at this corner. So it's probably this ribbon connector. It's probably the socket that plugs into. It's probably got a cracked solder joint or something of that nature. And I've already had to do some repairs to the tracing, because you can see where Moog, when they built this thing, they had a tracing change, which I'd mentioned earlier. But they had actually cut this one tracing and it was almost broken in half. These other two have been scraped. You can see all the way across here. But this one right here was absolutely just shot. And so I had to clean that up. Whoops. So I can get that camera to focus. But yeah, so I had to clean that one up. I still need to investigate some of these, make sure we don't have any problems here in the future. But that was definitely a problem there. So clean that up. And like I say, that's where they rerouted the external input. They put it on the shielded wire instead of putting it right there. They probably had a miswire or, like I say, crosstalk issue. So they just eliminated that and put a hard wire shielded running to the pots. But anyways, gonna see if I can fix this problem here real quick, get this signal to where it's stable, and then we can move on to some more gain stage. I have already found some differences in this board though. And there's actually a resistor added. You can see this little question mark I put on the board for myself. We got a 10 ohm resistor there on the 10 volt line that's not on the original Minimoog. So they've actually changed the voltage VCC going into parts of the VCA. So we got to look into that and see what's going on there. But anyways, keep you updated. Alright, now I got the interface board here pulled and just looking for anything obvious that would cause us to have intermittent VCA issues here. But just kind of interested how this thing works. So what they're doing, I'll just kind of explain what I'm finding on this board here for those that are curious. So what we've got here is we got the main power switch. Now keep in mind, on the original Minimoog, all you're doing with the power switch is switching on 120 volts. So you got 120 volts at the power cord through a fuse, goes to the switch, you turn the switch on, and it energizes the transformer, and then the transformer does all the voltage reducing. So it does all the AC voltage reduction, and then it goes into the rectifiers and the filter caps, and then it goes into the power supply, and then the power supply of course changes that to a plus negative 10 volts regulated. So what they're doing on this one is, because it works a little bit different as far as the power input, because we're now dealing with 3 voltages. We got the plus 15, negative 15, and plus 5. As what they're doing is they're using the switch here to actually switch these relays. So these are solid state relays here. And so when you flip the switch or turn on these relays, you got these capacitors here that work in 2 ways. So one way, they're actually a filter cap, but they're also working as a current storage. So when you turn this on, these are actually have stored energy, so you're not dumping a lot of current from the power supply. So this is actually how they're kind of using the caps as a kind of like a I'd explain it to people like a tank on a toilet. Like when you flush a toilet, it fills up with water, and that way when you flush it, you get this dump of current of water that you wouldn't have if you just simply ran a water hose into the back of a toilet. So that's kind of what these are doing. They're actually working as a current storage for the power supply, so you don't have a lot of load taken away from the supply itself. And then what we got, I'm glad to see some static protection in this thing. We got the TVS diodes, which are transient voltage suppressing diodes. They're not rectifier diodes. They're actually, what their job is they got a certain voltage that they're rated at. And you can kind of think of them like an emergency brake or a governor. So let's say that your external power supply went out of regulation. Let's say that, let's just use negative 15 for example. So if negative 15 voltage decided to go up to like 30 volts, you know, let's say something happened in this power supply, well, what this would do is it would start clamping down to ground. And the closer that thing got away from the voltage set point, the more this thing would clamp down to ground, protecting all your circuitry. So it'd probably finish up burning up the supply in this case, or it'd probably take out one of these resistors right here. Hopefully, I think these are wire round, so I don't think it actually would. I think these would just sit there and get hot. But what it would do is it would actually protect everything in the Minimoog from a voltage spike, basically is what that would do. Now these also probably work as far as initial turn on. It keeps anything from spiking on turn on. These can also be used as a sub-regulation kind of circuit. So I think that's what they're doing in this instrument here. But so far I'm just now looking for what's causing our intermittent VCA problem. I did run across something that's a little not real good. But right here we got these wires that's running across here. And it looks like these wires were installed. Let's see if I can zoom in and get this. Let me actually get a flashlight, that may help. My lighting right here is not that great. If you look right here by this pod right here, you can see the insulation is damaged. Because what they did, whoops, let's see if I can get that to focus here. Come on. But basically what we've got is we've got, right there you can see insulation is damaged where this pot was put in after these wires. And I can actually see metal. So I can actually see the insulation is actually burnt down far enough or melted down far enough that we don't have insulation on that. So that could be some of our problem. I don't know how that all works. I don't have schematics for any of this part of the Minimoog, so this is kind of a suspicious area. I'm just trying to kind of reverse engineer here. But anyways, it's right here, so you can see my pick. It's on this line right here. Let's see if I can get some better lighting. There we go, that might be better. Just kind of lift that board up, but you can see it right there where it's actually rested against that leg of that pot right here. And that's actually where it's burnt through the insulation when I heated this pot up to install it. they melted the insulation there. So that is one thing I'm going to have to look into and see if I can fix that, which I can fix it, no big deal there. But the other thing I'm just looking for is any kind of cracked solder joints. This is where our VCA connects, VCA filter board, etc. That's what I've got to look into here. But I am seeing a lot of like solder beads. Like this thing was never really properly cleaned. The flux is off of the board, but we just got a bunch of solder beads. I was going to see if I can find a place to really show you. My camera does not like to zoom in that far. Let's see if I can find a good spot here. Yeah, so example like right here on this edge. Let's see if I can get this thing to zoom in far enough. Yeah, you can kind of see them right there. You can see, let me get my pick here. I'm trying to do all this one-handed while holding this big giant camera. So yeah, so like you can see right there, like for example right here between these legs, you can see that little ball of solder. So I can move it around. So this thing does have little solder beads in it where it was soldered. And so I can move those things around. I don't know if you can see that or not, but they're right there across that trace now. So I can just bump them around. So I will be cleaning this board up to get rid of all those little solder beads. Now luckily this is all through hole, so it's not as critical. When you have through hole stuff or surface mount stuff, everything's really tight. So a little solder bead like that, depending on what grade of through hole component or surface mount component you're using, those could definitely cause shorts and bridges and that kind of stuff. And this is not as critical because we're talking about through hole components, but I don't like to see that because that can you know, if there's one big one on here somewhere that is overlooked, it could roll between something and cause problems. Luckily I don't see any big ones so far, just eyeballing it, but that is something I did notice, is there's some little solder balls in here where it was soldered and then not really cleaned up that well. But I don't see the flux, which is good. Sometimes I'll see like flux left behind. Like there's one spot right here you can see rework. Like for example right here, around that guy right there, you can see all that residue. That's flux. So that one has been redone at some point, rework, and it wasn't cleaned up. So that's what, if this thing had not been defluxed, it would look like that all over the connectors, and that is ugly. That is a nasty thing. I do open some sense up and see all that stuff inside there. But anyways, I'm going to get looking and see if I can figure out what's causing this intermittent VCA problem. It is in this board because I can wiggle the board down here at this connection point and it comes and goes. So that's let me know it is in this board here. I just discarded this wire that was suspicious and I wanted to just really investigate it here. And sure enough, it is actually touching this pot. So it's touching the wiper leg of that potentiometer there. And you can see that we can see the metallic wire inside the insulation right there. So it was actually touching. So that could be some of our problem. Not 100% that would cause our problem that we're having with our VCA, but that is a problem. And I believe this pot right here, if I'm not mistaken, this is the, I'm just kind of getting an idea of the layout. Yeah, this would be your noise source right here. So this would be your noise source amount, your volume control for noise. This is your noise source selection. So that touching the wiper, that could cause noise source problems. Depending on what this wire does, like I said, I don't have schematics. I need to look and see what this wire does, but through reverse engineering. But depending on what this wire does and it touches that, it could cause some problems like what we're having. So we're going to look and see where this wire goes. And I'm just going to continue to investigate. I've got all the glues broke loose that's holding these wires here in place so I can examine all the solder joints of the connectors for the ribbons, and we'll just kind of see what that is. But I just want to make a note of that right quick in video where you can actually see the wire exposed in there. Alright, I've now got the wires fixed here. I actually ran into another one. This one over here had the same thing where the pot was soldered in before these wires, and it actually caused the same thing on this one as this one over here had. So what I did is I desoldered the wire, and this is a solid core wire. So I was able to lift the wire up and actually rotate the insulation away from where it had got melted. And then so it's now got a fresh insulation against this pot, and I also shrink wrapped it so the area that was open will not touch anything else if that was the case. But just going to do that. Same thing over here. And just been investigating everything, looking things over. I did touch up a few vias. I got to clean the flux off, as you can see right here. I did touch up a few vias because this is a double-sided circuit board, so some of these tracings go to the other side through these vias. And so just touching up anything that looked kind of suspicious there. And also I cleaned up the little solder beads that was on the connectors. You can see that they're no longer there. So we got all that cleaned up, so we no longer have any solder beads. And what that would cause, if you're not careful, is that can cause something called FOD, which is foreign object damage, is what that stands for. So we got rid of all that. Also, upon more evaluation of the power here, I want to clarify something. So I was looking at how this relay is connected, and these are just simply filter caps. They're not booster caps like I thought they were. Because what happens is the power comes in from here, from this connector up here, goes through these resistors here, the shunts, goes into your TVS diodes, and then it goes into your relays. Now these TVS diodes are not in series, they're in parallel, they're with ground. So that's how it does, it's clamping, it clamps down to ground, that's how it protects its circuitry. But basically what happens is the power is sitting on the relay, and then when you flip the switch, the relay turns on, and then it actually energizes these capacitors. So these capacitors are just simply filtering caps, they're not boosters like I had thought. So just want to clarify that real quick after looking at it a little closer. But anyways, I'm just gonna keep looking over this board a few more minutes, see if I find anything that looks suspicious. So far I haven't found anything except those wires, and I guess we'll put it back in, see if it does anything different as far as the behavior of the VCA issue that we've got. Getting ready to reinstall the interface board here, the right side, and I'm just going to show you how this thing looks for you technicians out there that will be working on these things. So you've got your ribbon cables here, 2 ribbon cables that plug into these connectors here for the left hand side of the interface, and pretty much everything's plug and play. So your power has a jack, your pot light has a jack, headphone jack has a plug, and then also even your overload light has a plug over here. Now these 2 wires coming out here, that's off the actual external audio potentiometer, and so one of these connects to your aftertouch board, which you have to remove also to get to this board, and then the other one actually goes to the filter board, which I'll show you pictures here in a few minutes of how these things wire in. Next, we've actually got the plugs, and I've got the cables laying on my table over there. This is actually where your filter board plugs in, power supply plugs in, and of course you got test points, so you actually can test your plus negative 10 volts right here in ground reference and all that good stuff. You can actually test them there. But like I say, to get all this out, you got to remove those little standoffs that go down here. So you got to basically take the bottom chassis off, take these out, take the MIDI board out, take the aftertouch board out, and also hold your audio output and input jacks as well. So here's what it looks like here, and like I say, it plugs in as well. It plugs in right there to the back of this board, and that's how that works. And then also your MIDI board, this is just your MIDI jack board here, is it's actually held in with those those 6 little small screws. So we got these little bitty screws here that hold that in, and that's all that supports this thing, which I'm kind of shocked at that. I figured there'd be a standoff there. But also, in order to get the jack board out here, same thing, I'd remove the standoff for the power supply because it fits through this hole right here, and so in order to get the jacks to clear the holes, you have to remove that standoff in the same way. Also, just like the left hand side, there is 2 screws right here. You can see that hole there and that one, and you want to add a lock washer or a Loctite there as well, just like on the other side I had mentioned. And that's the only 2 screws on the back of this one. Everything else is held in place by the potentiometers. And also, just once again, when you pull the pots, so you have to take all the nuts and washers off here, is do not remove the external audio volume pot. It's actually it's independent from the board, so you don't have to worry about removing that one. But everything else comes off just like so, and that's how it goes. So I'm gonna put this thing back together. We'll test it out, see if we still have the same intermittent problem, and hopefully we don't, because it is quite a bit of work to tear everything down to get to the front boards here. Alright, I just got this Minimoog all back together, and it looks like we've solved our problem. If I had a key here, we'll make the envelope set for a long time. There's our filter, there's our signal. I can push on the board, no problem. So evidently, it was actually those wires touching the potentiometers, because that's the only thing I found that looks suspicious at all. And took care of those two wires, and now it's no longer intermittent when I push on the board. So I believe we fixed that problem. So now I'm just going to continue to move on and get back to what I was doing here with the filter. Alright guys, I finally have the Reissue Minimoog all closed back up here, and got it sounding much closer to what we were after as far as the sound goes. And learned a lot on this particular Minimoog, because this is the first reissue I've really had my hands in, and really deep, you know, as far as like taking things apart and matching and testing and all this kind of stuff. But anyways, my primary focus was on the filter in the VCA. That was my primary focus. I took tons and tons and tons of measurements, even just between other vintage Minimoogs, to make sure I wasn't you know, missing something. So I got a baseline of what normal is. And so that was really helpful to figure out what we're dealing with here. And I did run into some differences. Now, the differences I think are based off new components versus vintage components, you know, the tolerances and that kind of stuff, because I mean, we're talking about 50-year-old components that have been, you know, used versus a unit that's only like, you know, just a few years old. So much difference there as far as you know, the wear on the components, and also just the change in manufacturing of components. So that too plays a role. But my primary focus was taking peak-to-peak readings, AC as well as DC offset readings, just to kind of get an idea of what we're looking at inside the filter, inside the VCA. I did some downgrading to this thing, so I made it more like a 72 Minimoog as far as some of the gain staging and that kind of stuff. And I learned some things too, like I said, about the input. So when I was first doing the testing, I started with the input of the VCF, of course, because that's where you always kind of start to see what you're dealing with first. And that's where I ran into the first big, you know, big thing that was different. And what it was is actually when you have your volumes for your mixer set at 10, it's not the same as 10 on a vintage Minimoog. And so I did all these tests with one oscillator on, one note reference, and so I could keep an accurate, you know, measurement across two Minimoogs here. So when you're in 10, the input of your filter is getting, it's 1.07 volts peak to peak on AC. And that's a lot of signal for one oscillator. The vintage Minimoog, when you're at 10 on it, you're only getting 800 millivolts peak to peak, and that's across a couple of units. You know, it varies a little bit. You'll get 800 to, you know, maybe 850, 860 millivolts, but still within the 800 millivolt range. And that's just one oscillator. So you can picture that 1.07 with all three oscillators on. That's a lot of drive into that filter. And so that really makes the filter muddy. That's why we heard that really muddy filter at the beginning of the video, because I did not realize that. And that was something I learned about manufacturing. So what you can do if you have a reissue Minimoog and you want to get it sound closer to a vintage Minimoog, back your volumes off to about just a little above 8 on your mixer settings, and that will get you a lot closer to the 800 millivolts that we find in the vintage Minimoog. So that was number one. That was the big thing that was changed, because of course if your input's hotter, everything's going to be hotter in your filter, so it's going to affect the you know, the way the filter, you know, reacts to the harmonics. So that was number one, and then I went to the output of the filter, and of course those look good. They were matched to a 75 era Minimoog, so everything was kind of based off a 75 Minimoog when they were designing this thing. And so I did some changes there to bring the gain up to make it have more drive into the VCA, and then change some things in the VCA. So did that, and then all the signals look pretty good there. The only other thing I saw that was definitely different was the DC offset out of the filter. So the reissue only has like 1.98 volts DC, And the vintage Minimoogs, and this is across a couple of units, it averages around 3.58 to 4 volts DC in the offset. So that's a bit different. I don't know how much that matters because that's for the coupling capacitor. So your coupling capacitor, of course, catches the DC and strips it away from the AC. So it may not be that big a deal, but that's just something I want to note. And that's probably all back to those transistors and just spec of components. I did actually pull the transistor ladder apart. I dissected it, and I rematched all the transistors within the in the ladder, and they all look really close. They were all like within 2 millivolts, 1 millivolt of each other, and so everything looked good there. And because I usually like to rematch all that because it just makes the harmonics better, and I can definitely tell when Minimoogs get in here and they're out quite a bit. If they're really drastically out, it's very noticeable. Slightly out, it doesn't matter as much. But so I just want to check all that and make sure all that looked good. And of course, the current source for the VCF is great. It tracks the keyboard fine, so I wasn't worried about that. That's another issue I deal with a lot with vintage Minimoogs. So anyways, with all that said, I'll now show you how this thing sounds. So I've got the mixer backed off a little above 8 on our mixers for their oscillators. Got these turned all the way at 10, so we're right exactly identical with the input of the VCF. And so I'm just going to show you how this thing sounds. So right now we got the filter opened. One oscillator, I'm going to do the same test I did earlier, where I close up the filter a little bit and do a cutoff sweep, and just kind of give you an idea here. So here's the raw oscillator. There they are together. So that's just the raw oscillator. You see my light flash refrigerator kicks on, I always mention that. So now what we'll do, we'll close up the emphasis to about 8. So we'll set the emphasis to 8 on both Minimoogs. And I'm going to go and turn on all 3 oscillators here, just so you can hear, make sure the oscillators are fairly tuned. Let me do this right quick. There's all 3 oscillators with the filter open. So you hear how great that thing sounds there. So now let's close the filter up. So I'm going to set the emphasis to 8 once again. Start with the reissue, and I'm going to do a filter sweep to -2. So we're at -2. Same thing with this Minimoog. So you can hear the filter's a little. It's pretty close there. The knobs, once again, when you adjust these things, it don't take very much movement to knock them a little bit out. So. Something else I noticed too was after I did the gain staging changes and that kind of stuff, is that our actual emphasis and cutoff set pretty close to the same points. So they were way different when I first started. Now they're actually fairly close to where they need to be. And of course this is after calibration, so everything's been calibrated. But anyways, that's the filter. So now I'm going to sweep the cutoff back open. Same thing on this one. So there's our cutoff opened up. Now actually what we'll do, I'll show you the filter tracks the keyboard, so we'll sit here and get this 440 Hertz on. I'll turn this off here too. So here's the filter of this one tracking. Let me go and get this one set up as well. Use the same 440 hertz. There we go, so the 440 hertz is off. So here's the reissue. Once again, I got a bad contact. So there's the two filters tracking the keyboard there. We'll turn tracking off here, put harmonics back through it, the oscillators. We'll go to square wave. We'll kind of play it like a Minimoog now. We'll just kind of do some sound testing here. So anyways, you can hear it sounds really, really good. It's sounding really, really close to what the vintage one sounds like. The filter may still be a little hotter, but as far as like the actual peak-to-peak voltages and everything I'm showing, it's the same. It's just that DC offset. So like I said, I don't know if that affects things a little bit, but or if it's just the new components. I think it's really just down to new components. But like I say, it's really close to my ears. So anyways, that's the Reissue Minimoog now, and I hope you guys enjoyed watching this little series video, and hopefully it's been kind of a eye-opener for the Reissue and kind of what it is, and now you can kind of hear how it sounds with a little bit of downgrading, and like I say, I'm happy with it. One other thing I will show you too, I almost forgot about this. So Michael was having issues with the overload in this one. It's actually hardwired in the Reissue. And he was saying that it would do some really crazy stuff. I think it was caused by that wiring that was shorted to the pot that we found earlier when I was looking at the interface boards, because I hadn't experienced that. It's actually got the overload like if you were to plug into the low output and then plug into the external. That's kind of what the gain sounds like. So as you can hear, I've actually put a patch cable on mine. You have to plug mine in because it's vintage. So we'll do the same kind of. This one may have a little bit more bite, the vintage one. I'm backing off to about 8 on it, and that's at 10. So there's a 2 there, but like I said, it's not the gain like if you were to plug into high output into the external input. That's a really over distorted sound. And one note for you guys that on both the Reissue and the vintage Minimoogs, you don't want to sit there and keep this light on. It's not good for the circuitry. This is like a clipping light. And it's not as much about the audio channel as it is the transistor that drives this incandescent bulb. This is actually an incandescent bulb. It pulls a little bit more current than what an LED would, and it actually will burn open a transistor if it just sits there and stays on. It burns open a transistor, and then you lose your overload light. So just keep that in mind for you guys that like to use the external input. You just want to set it just where that light just kind of burns dim. You don't want it to where it's just hard on, because you will damage that transistor in there. And I get them in a lot of times when people use the overdrive, and that's what happens. They burn up the transistor. But anyways, I just want to take a quick minute and show you the external input there. But once again, Michael, I really do appreciate you letting me work on your Reissue for you and getting my hands kind of dirty in one. And for you guys that watched this video, appreciate you watching. And there'll be more here to come here very soon. Take care. One other thing I did want to bring up real quick that I almost forgot is I wasn't able to actually work out the 32 footage. So when you're in 16, you're in 32, so you've actually got an octave lower on the Reissue. So if we just listen to that one oscillator, we'll open the filter up here. So there's 32. Here's 32 on this Minimoog. And here's just a click. So you have to go up a note. So the same thing I'd mentioned on the earlier part of the video, that was something I ran into. Something else I noticed too, I want to bring this up. The pitch wheel does not have a dead zone mod, and I didn't really want to dig into that because that's a whole different circuitry design down there for your aftertouch and everything. I just didn't want to get into that. since it wasn't giving you any problems there. But if you notice your wheel, so we'll set up these oscillators here the same. Go sawtooth here. Helps with a higher frequency here. See, we actually got an 8 on this one. So now if we wiggle the pitch wheel within the detent, you'll hear a tuning instability. See here, it's like you bump it, and it's gives it a little bit of variance. Whereas my vintage Minimoog has the dead zone, so you'll see it's actually accurate. So you can see it's accurate when it's in the detent. So that's a difference I did notice there. I'm surprised they didn't do a dead zone on that pitch wheel in the design. But just like I said, I didn't get into that because that's a whole different area, whole different design. And I already had to do a lot of reverse engineering just to figure out some of the stuff in this one with the ribbons and everything. Well, change of plans here. I've decided to go and add the dead zone to the pitch wheel. It's just too random. And I was playing with it like a Minimoog, and I'm finding myself, you know, with tuning problems and that kind of stuff because of the dead zone. And so I decided to pull this thing out and just take a look at it and see what I can figure out here. And I found everything I need. Sure enough, it's not dead zoned at all. It's still got the old style Minimoog setup. I'm not sure about the quality of these pots. They're using burns now. Those are burns, but they're just kind of a smaller pot for that kind of aggression area. You know, where you play really hard, you kind of need to see like some kind of big robust pot there. I imagine that'd be a problem. They glued everything too. You just put silicone on everything. So that's kind of ugly to me, but that's how they did it. But anyways, I'm going to see if I can get the dead zone added here. I'll have to add it here, and then I'll have to modify the oscillator board as well to make it work with the dead zoning. But I'll keep you guys posted here. Alright, I just completed the dead zone mod, and I got that fixed. It's almost like it was made for the dead zone. I had to add the summing resistors and everything to it, but as soon as I did that, I've actually got the 32 footage correct as well. So why Moog didn't do that? That's a question for you. I don't understand why you wouldn't. But anyways, here's 32 octave compared to the original Minimoog. So we're in 32, 16 of both. So there we go. So our footages are right, as well as our pitch bend now doesn't have any wobble in it or any weird pitch. So you can see I can wiggle it within the detent. That's like night and day playing this thing with the pitch wheel now. So those are 8. That's why we're on different waveforms. Just trying to figure out why it sounded so different. So I still have the back cover off this one just because of me working on it. I haven't put it back together yet. I just want to make sure everything was going to hold up here. Yeah, that's way different. Having the correct footages makes a world of difference too. You don't really think about it, but it really does, especially when you're playing two Minimoogs. But anyways, just make an update there on the dead zone, and you can see now how great that works, and I'm really happy with it.